Hello, I'm Sidesh and I'm a part of the technical team at Tala Security. Through this session, I'd like to help you better understand client-side threats, the relative ease at which web applications are being compromised, and some actionable next steps on what you can do in the near term to safeguard against this new age threat. In this session, I'll go through an introduction of the problem, and then we'll spend around 10-15 minutes going over a live attack demo. And then lastly, we're going to finish off with some of the defenses that you can apply to help your organization. No prior knowledge is required to understand this session. And this presentation is for anybody that uses a website or is responsible for web security. By the end of this session, you'll hopefully have an understanding of how vulnerable web applications are on the client side and the increasing need to implement client-side security. Let's get started. I'm sure everyone has heard of the recent SolarWinds breach and the large impact that it had on several enterprises. The part that I would like to focus on is how software supply chains are being exploited and how these attacks are gaining relevance everywhere today. So let's break down the SolarWinds attack and look into some of the reasons why it was so devastating. First of all, SolarWinds was a trusted SaaS vendor. Enterprises trusted the company and the software that they delivered. It was widely adopted, and a single compromise led to over 18,000 breaches. And from an attacker's point of view, these types of attacks are especially attractive because they give the attackers remote control access to their end servers in a way. So this is how the SolarWinds hack went down. And I'm sure you're thinking, how does some IT management software affect web application and web security? Let me explain by quickly going over how web architecture has evolved over the past 10 years. Web architecture for the past decade followed a trend where the applications were server heavy and enterprise data centers handled the bulk of the processing. The web browser during this time was more of a graphical interface only. And as we look in the past few years to today, the architecture has evolved for many reasons, including optimizations that enterprises want in terms of speed, as well as increased computing capacity on the client devices, that is your PC and your mobile devices. As a result, today's websites integrate dozens of third-party vendors, all the way from your user analytics, marketing tags, CDNs, open source libraries, and so on. This has led to third-party vendors and libraries loading their content directly onto your browsers. And this means that on average, around 70% of what loads on end users' browsers doesn't come from first-party servers at all. Enterprises are designing client-heavy applications as a result that are run through JavaScript on the browser. And these browsers are acting as the modern-day OSs. So this is how a typical web application and website loads their content today. And as you can see, this diagram shows the different third parties and their multiple locations and data centers that are situated across the globe. Hopefully, this sort of explains why the internet is called the web. So in this, your JavaScript loads third-party JavaScript, which in turn may load fourth and fifth party JavaScript. This is called the piggybacking of JavaScript, and this creates a trust between you, your third party, your fourth party, and so on. And as a result of this trust model, it only takes one of these libraries or dependencies or even one server to be infected in order to compromise your website. And this is the main principle that is leading to website breaches on the client side. And as you will notice, your data center or any of your servers, they were not impacted, they were not breached or attacked in any way. But still, your end users, they got infected with this malicious JavaScript. Google researchers that work on Chrome, they say that if an attacker is able to inject any JavaScript in end users' browsers, it is practically game over. So now, if we combine the principles of the SolarWinds style supply chain attacks and how websites are using a large number of third-party dependencies, the modern web has become the perfect storm. Here's the breakdown. We already have JavaScript as the one common language and framework that powers the entire web today. And one JavaScript can load another JavaScript and so on through the implicit trust model that we just saw that's present in the web today. Finally, many popular JavaScript libraries are deployed to over thousands of websites. In fact, a recent study that Tala conducted analyzing over 1,000 websites, the Alexa 1K, highlighted the startling number of third-party services an average website uses. And that number is 34. What was more concerning through this study was the lack of security controls that the top 1,000 websites in the world have against such types of vulnerabilities and third-party breaches. This seems a little scary, right? So in the next section, I'm going to be showing you a live attack demo. But before we switch gears, there's one situation that I'd like you to think about. Imagine if one of your third parties told you that they have been breached. What is protecting your web application from being compromised today? So now we're going to switch mode to an attacker's point of view. I'm going to act as an attacker now, and I'm going to share my thoughts while we're going through an attack together. So as an attacker, I'm going to try and exploit the weakest part of armor that the web application has. I know that your WAF only protects your servers, but the content that is served from outside your WAF, that's less protected. There's a growing saying in the industry over the past few years that goes like, if you're only having a WAF, an attacker is having a laugh. So with that in mind, I'm going to try and target the servers that are outside your data center. All these servers that are on the right-hand side of this diagram, these are much easier targets. Let me show you how a typical website attack takes place in this case. First of all, these style of attacks are called MageCard. And MageCard is also the name of the most infamous group that carries out these hacks. And without going off on a tangent too much, let me present an analogy from the physical world. I'm sure you've heard of the credit card skimming attacks that sometimes take place at gas stations. They go something like this, where you swipe your credit card at the pump and some attackers or somebody has put in a small little hardware that steals your credit card number and stores it somewhere. Your transaction at the pump, it goes through okay, and you cannot detect anything is wrong at that time. However, after a few weeks, when you check your credit card statement, there are some mysterious charges that have been applied that you've not made. So, similar to these physical credit card skimming attacks, we have web-based JavaScript skimming attacks. And that, in a sense, is what the MageCard attack is and what the MageCard group does. Let's take a look at the typical steps in a MageCard attack. Step 1, the attacker will try and find out what goes into your web application. That means listing out all your third and fourth party dependencies. Once the attackers identified a suitable target, they'll use all appropriate means to breach into the third party servers. This can be achieved using any of the standard attacking and hacking tools, all the way from credential theft, SQL injection, RDP attacks, rainbow tables, whatever you can think of and that has been known or unknown, the attacker will try and use that to gain control of the third-party server. Now, once the attacker has control over the third-party server, they were going to try and insert their own little JavaScript in there. This code is designed to avoid detection, and it will maintain a low profile. We'll go over how attackers are doing this in a few slides. Now, when an end user navigates to this website, their browser loads the third-party dependency, and ta-da, you have been infected by the attacker's JavaScript. By inserting one JavaScript onto your browser, an attacker can do a lot of nasty things. They can deface your website, inject their own ads, do Bitcoin mining. But over the past few years, attackers have realized that the best way for them to monetize on this is to try and steal end user data. That generally means your credit card numbers, your username and passwords. And that's what attackers will generally go behind. And this is actually what happened a few years ago on a ticketing website in the UK. Attackers must have thought, hey, look, a lot of people are going to book their tickets on this website through their credit card, and let's try and steal it. Or they couldn't book their tickets to their favorite concert, something like a Justin Bieber concert, and got pissed and decided to hack this website. It's something like that. But at the end of the day, they decided to try and target one of the ticketing website's third parties, that is Inbenta, and they injected their own JavaScript after hacking into Inbenta's servers. Now, when end users went onto the ticketing website to book their concert tickets and so on, their credit card information was being stolen. And as a result of this type of attack that the MageCard group did, they were able to steal over 60,000 credit card numbers on this ticketing website alone. For my attack demo, I'm going to perform a similar set of steps in order to show the attack. For my attack demo, I wanted to use a well-known public website to show you how we can attack it and have some little hack funds. But thanks to the legal team, I had to settle for a demo website that I created and own. I have not hacked or done anything illegal against any other website or server, and this demo is just an example. So for this demo, this is the target website that I'm going to use. And for the first step, I will want to analyze the target website to understand its supply chain and look for any possible weaknesses. For this purpose, I'm going to use Z-Attack Proxy, also known as ZAP. And this is a great open source tool for attacking a web application. What this tool does is it crawls the web application and understands all the resources that are loaded. It can optionally also run attacks or pen tests against some of these resources. So please get permission before running ZAP against a website. This is the start page of ZAP. and I'm going to run a scan against my target website. I've set the options in Zap already so that it will try and explore all links possible and look for all the resources that are present on this website. So let's hit off attack to start the process. As this website is quite small, it will only take a few seconds for Zap to trace all the dependencies, all the third parties that are present on this site. As you can see, there are quite a few first-party resources that are loaded, and also some third parties that you can see are getting loaded here. Let me show you a graph for better understanding. Yeah. As you can see, the target website, it loads quite a few third parties, and I did my research on them all. I found out that View Analytics, the one which is on the lowermost side of the diagram, that is actually an open source analytics library. And this is great news for me. Why? Because for the past few months, I have been contributing to the open source community quite a lot. I've gained their trust in this time frame. And just last week, I put in a bug fix. And I also slid in another dependency to fetch one small JavaScript from my servers. So now, when you load the target website, your browser is going to fetch an infected View Analytics script, which brings us to the next step of the attack. The attack payload are just these 5 lines. And these 5 lines is all that it takes to perform a data exfiltration attack that I will be demoing. In this case, the attack steals the username and password. Let me walk you through this at a very high level, and no programming knowledge is required to understand this. The first 2 lines say, let's read the username and password values when they're typed in by the end user. That's how easy it is for one JavaScript or any JavaScript to read anything from a web page. And the next 3 lines say, hey, let's send this data out to badserver.com. And that's all there is to data exfiltration in JavaScript. Okay, let's go to the target website to see the actual attack. This is regular Chrome, and on the right-hand side, I have opened up developer tools on the side so that I can explain the attack better. I will be able to explain what's happening under the hood, side by side to the website in this manner. So let's go to the website. So as soon as the website loads, under the hood, I can see that the attackers already loaded in their attack script through View Analytics. On the left-hand side, nothing seems to be amiss. The website loads properly and everything seems good. So let me try and log in. There we go. The login went in successfully, and I didn't realize anything's amiss. Frederick Gordon can go about doing his usual business after logging in. But what's happening on the back is that a copy of the username and password is sent back to the attacker's servers. In this case, it's myattackservers.com. As you can see, here are the username and the password that was sent back to these servers. In this case, the attacker is only printing the logs just for this demo. And that's how easy it is for credit card numbers and username and passwords to be stolen, and then later sold to the dark net. This is steady income for any attacker, and one US credit card can go for around $7 on the dark market. So for such attacks, some of you may think that these attacks are easy to stop or detect. Well, not really. Attackers have a few tricks up their sleeves to ensure that these attacks are not easy to detect and don't go detected for a very long time. The average Mage card infection is 46 days. Here are some of the reasons why these attackers are so successful and why these attacks are so hard to detect. The attackers will first of all use the standard techniques. They will obfuscate the code and ensure that no static analysis tools is able to detect their malicious behavior. Here's where the attackers get a bit more creative. So the malicious JavaScript that they put in, it will not perform anything malicious if it realizes that your dev tools are open. They're quite smart about this, and they do not want to get detected by some security engineer keeping their dev tools open and trying to understand this behavior. And I'm sure some security engineer will be smiling and saying, aha, I'm going to try and use Wireshark to trace all the network connections that go from the browser. What time do you work? Because these attack scripts, they only load from 1 to 4 a.m. and that too on certain randomized days on certain geographies. And even during that time, the malicious behavior only occurs for around 20% of the time. By that, I mean to say 80% of traffic at 1 a.m. to 4 a.m. is still completely clean. And you won't even realize there's an attack taking place to the other 20%. Lastly, I wanted to add that the network request to fetch the attack scripts is exactly identical to the other 150 network requests that the browser makes in those 2 seconds. How are you going to distinguish the good and the bad? It's like finding a needle in a haystack, in my opinion. And that explains why these attacks mostly go undetected. In fact, a few years ago, when Symantec analyzed over 1,000 form jacking attempts in just a 3-day period, they found that over 57 websites got hit with MageCard. The websites that got infected ranged from a fashion retailer in Australia to a fitness reseller in Italy. And regulators have started taking notice and imposing very large fines on the main website directly, not just on the third parties, but the main website. And these attacks are causing significant financial damage, not just in terms of these fines, but also class action lawsuits, as well as a loss of customer loyalty and trust in the brand. So now that you've seen how these attacks have transpired and how they're gaining momentum, let's talk about what you can do to protect yourselves. And at this time, I'm just going to try and say that you have to use the basic security principles of defense in layers. In other words, using RSA Conference's theme for this year, build resilience into your security. Create layers of defense around your web application to increase security and redundancy. So, you cannot protect against threats that you do not know about. And the first step, or the first layer of defense, is to understand all the third parties that integrate with your application. Next, let's try and minimize the number of third parties that are loaded on your web application. Layer 3 adds an active protection to your web application so that it's protected even if a third party has been breached or attacked. And lastly, you should be on the constant lookout for any signs of potential breaches from your third parties. Let's double click on each of these layers to understand these defenses a bit better. So as I was saying, you cannot protect against threats that you do not know about. The first step is to identify all third parties that your application loads. And more importantly, all the third and fourth parties that are loaded by your third parties. That is, the fourth and fifth party JavaScripts that have been piggybacked on through your third party. It also helps to prioritize certain pages that have sensitive user input, such as login pages and payment pages. And try and classify third parties based on how severe of a breach it would be to your web application if the third party got compromised. When it comes to security, like many things, I'll say learn from the best. And Google is definitely one of the good champions in web security. What you're seeing here is a typical login form that you've seen 100 times, I'm sure, while logging into Google. And on the right-hand side, I have the developer tools open, which has been set to filter out only third-party resources. And as you can see, that list is empty. That is, Google doesn't have a single third-party JavaScript on this critical sensitive page. And that's definitely an easy route that you can take to protect your web application. Minimize or reduce the number of JavaScripts that are loaded from external sources. Sure, this is not feasible everywhere. And sometimes there is an essential JavaScript which you require, which is a third-party JavaScript. You can consider self-hosting it, and that will make the third-party JavaScript a first-party JavaScript since you are serving it directly. The active protection layer, in my opinion, is the most important layer of defense, and it addresses the worst-case situation when an actual third party is breached. These active protection methods allow your web application to successfully defend itself against these malicious third-party libraries in real time. These protections are for web applications through W3C and HTML5 standards. They're deployed through HTTP headers or in the page body. So here's how the typical workflow takes place. When a browser requests the web application, it comes with these protections that the browser then enforces. These standards are enforced by the browser. So when your web application makes a request to fetch any third-party resource, the browser ensures that these resources that are loaded are secure and trustworthy. You're basically telling the browser to be responsible for your web application security now. And the best part is 94% of all internet traffic today uses a browser that supports these standards. And these standards are free to use thanks to W3C working groups. Let's take a look at the 3 most important security standards on the client side and how they would have protected your website from the attack that I just demoed. The first one is content security policy. Through this header, you can control what comes in and what goes out. For example, you can list all the third-party domains that are allowed to bring resources into your web application and all the domains that data can be sent out to. Content security policy would have prevented the attack that I demoed by not allowing the script from my server to load in the first place, my malicious server to load in the first place. And further, it would have also blocked the outflow of data, that is the data exfiltration, because the attack was sending the data to a new server. The second one is sub-resource integrity. And this standard verifies the hash of a third-party script in runtime, and it blocks the script from running if the hash doesn't match. If SRI was protecting the view analytics script from the earlier demo, then the browser would not have liked my malicious modification of the script. The hash would have changed, and the browser would not have permitted the script to execute at all. And a third powerful standard is the iframe sandboxing. This is a feature of modern browsers that allows a third-party script to be fully isolated from the main website. And if this was deployed during the attack demo, the attack script could not have read the username and password values. This is because the browser would have made the attack script run in a completely isolated context as compared to the main website, which had the login form. W3C and HTML5 standards can control over 100 different browser behaviors that range from security to privacy and compliance. As these standards are enforcing security on the browser, that is the client side, that's why they're called client-side security standards. I'll definitely recommend that you spend some time to get to know these standards a bit better and also to set up some standards for your website. I generally don't like to explain a joke or a meme, so I hope you get the irony when there is a third-party service JavaScript that claims that it can protect against other third-party JavaScript. The main security downside of using one defense JavaScript against an attack JavaScript that are operating in the same privilege is that this is not good for security. You want your defense JavaScript to be at a higher privilege than the attack. And when that does not happen, like for JavaScript-based solutions where they're the same privilege, the attack JavaScript can simply get rid of your defense JavaScript. You always wanted your defense to be at a higher privilege. And the W3C standards from the previous slide, they've been publicly scrutinized and are recommended by the security industry as a whole. Rather, they were even created by the security industry, actually. The JavaScript-based solutions, they're also not free to use like the browser standards, which we mentioned earlier. So now that you've added in sufficient defense to your application, what's next? You got to stay ahead of your adversaries and build a layer that can keep a track of all the third parties and preemptively take action when you feel that there's something going wrong with one of your third parties. Now that we have understood the defenses in theory, let's take a look at a sample web application that has implemented these defenses. In this case, I'm going to act as the website owner and walk you through that. So first of all, I know all the resources and third parties that are in this website and web page. I've examined them all and reduced the number of third parties that are loaded. The one essential script that was really required for my application, I have protected it through a sub-resource integrity hash so that no one can tamper with it. Plus, I'm also using a strong content security policy to ensure that no extra scripts are loaded and no other data can leave my web application. Lastly, I'm periodically checking all my third-party scripts and vendors to ensure that they have not been tampered or breached in any way. As we're coming to a close of this session, I hope that you have a better understanding of client-side threats and the ways in which you can safeguard against this new age of threats. For the next steps, I'll recommend that in the coming weeks, you try and perform a resource inventory of your website. In the next few months, get a CSP, use an SRI, and be ready for the worst case in case a third party is breached. And lastly, pass on this message to other security professionals in your network and in your company so that they too can protect their websites and web assets. And if you're interested in knowing more, Tala Security has been working in this field of eliminating client-side attacks for the past 5 years, and we've published a few white papers on this topic. You can access them through the QR code. And there's also a link to our website, which has a lot of free resources to help you get started and secure your website. You can also feel free to reach out to me on my email address or connect with me on LinkedIn. Thank you, and there's a Q&A session that is coming up next.